Hello, ladies and gentlemen, and welcome back to another screencast by Mr. Stano, your Earth Science teacher. And we're going to continue on within the meteorology unit. Last time we left off, we were talking about cloud formation, and now we're going to go on to precipitation, very closely associated with it. Precipitation, as most people think of, is going to be either rain or snow. But it could be a number of other things. We could be looking at hail, sleet, ice, any form of water that has basically condensed falling from the sky is going to be known as precipitation. And we can have a mixture of these, or we could just have one of them. So precipitation could be rain, snow, hail, sleet, ice, and I'm sure I'm missing a couple on top of that, but for the most part, this is going to cover a majority of them. Precipitation is associated with cloud formation. Most people think of a raindrop of having that characteristic teardrop shaped. Big blue there, look at that. Much like we see here. That is not the case. That is not the shape of a raindrop. Depending on its size, its shape is going to change a little bit. Very small droplets are going to be very circular. As they get bigger, they have a greater effect of air on them, or air resistance. And what happens is their shape changes. The bigger the drop, the more resistance the air it has, so its shape changes. It gets more elongated. Eventually, what happens is these really large drops will split, forming two smaller drops as it falls through the sky. So most people pick this, and that is not the case. It is not teardrop shape. So smaller drops tend to be more round, like this, and larger drops tend to be more like this one or this one right here. The raindrops themselves form from the constant accumulation of drops. So remember, a cloud is nothing more than water vapor that is condensed around condensation nuclei. And they're held up in the air by these currents, these air currents going upwards at low pressure air. Well, if this droplet hits into this one right here, it'll form one bigger drop. And if these three drops hit into each other, they'll form one bigger drop. And then these right here, one bigger drop. Now they have more mass, they're heavier. What ends up happening is the drops themselves are then able to start to move downward against the air that's holding them up. Even if these drops all hit together here, now they get even bigger, and they can fall more. And that's basically how your raindrops form. They form from the collection of condensation nuclei, which has water condensed around it. So they collect, hitting into each other, and eventually get big enough to fall downwards. These are rain shafts. Rain shafts are pretty cool, normally associated with our anvil clouds. So we have our rising air. And what happens in these areas, we have these really strong currents of air pushing down. As the air pushes down, it brings the rain down with it. So you have this really high or fast moving rain. But typically, rain will fall at an average speed of 14 miles per hour. That's typically, it may change a little bit depending on the currents that are either going upwards off the ground or lower pressure, or that if they have anything like we previously saw with the rain shafts. But on average, 14 miles per hour. Hail is a great story. Hail is moisture that freezes in the clouds during warm weather. These are associated with tornadoes, occasionally with late summer thunderstorms. We also see hail, but it's pretty cool how they form, and the next picture is something pretty important. And here's that picture. I would definitely copy this picture down in your notes. I'm going to go through it, and it'll probably come up in class also. What we have here is we have our typical low pressure system, bringing it up, bringing our air currents up. When that low pressure rises, that warm air rises, it takes the raindrops and it brings them higher up. Remember, as we increase our altitude, temperature decreases. Well, if these raindrops go high enough to the point where they freeze, then now all of a sudden the water drops are H2O solid. Well, that's not the end of the story. They eventually get high enough, and then they fall down. They fall down where they melt. And guess what happens? They hit into more droplets, they get bigger, and then they come back up again. and they refreeze. And this cycle can continue and continue and continuing on. Keep circulating through the cloud as these convection currents are moving these particles between melting and solidifying, and then melting and solidifying. So as this happens, we can get bigger and bigger and stronger hail. So in some areas of the country, we see these hail that are as big as baseballs. That's because they were stuck in this loop or this cycle for a long period of time because extremely large low pressure system or rapidly rising air has allowed them to happen. Then we move on to this guy. So we did rain, we did hail, and now we're doing snow. This is Mr. Snowflake right here. This is Wilson Bentley from Vermont. And he was basically the first one to really start photographing snowflakes. What he did is he did it outside in the cold conditions, and this is what he found. This is what he was able to do, is take photographs of snowflakes like this, and notice that they all have 6 sides. Very similar to precipitation. It's just that this freezes up in the cloud and then eventually falls down to earth, usually with a little bit weaker updrafts. Okay, that's it. That is the end of precipitation. We didn't cover them all. As we go through class, we'll definitely cover more of them, like sleet or ice storms. But for the most part, these are 3 major types of precipitation that we see. And like I said, we'll cover more in class. The next time we meet, we'll talk about the orographic effect. Until then, have a good night. Take care.